Back in 2018, an Embry-Riddle Aeronautical University Piper PA-28R Aero lost a wing while on a commercial rating check ride, killing both pilots on board. That crash prompted FAA AD 2020-26-16 that covers a large number of single-engine Pipers and requires inspection for wing fatigue cracking of the lower main wing spar. Now, future aerospace professionals studying in the Middletown Aerospace program at Middletown High School in Connecticut are learning firsthand what the inspection entails and the process for spotting component fatigue and corrosion.
So my name is Paul Pelletier from the Middletown Public Schools Aerospace and Manufacturing program. Like all schools, we've had to change due to COVID how we teach, and the students have done a public service here by studying the AD and learning, and then presenting to you what the Piper ADs mean to Piper owners. What we did is we took an old Piper aircraft that we had, and we took it apart, and the kids studied every aspect of the Piper ADs, the Piper PA-28 ADs that have just come out. And we were able to teach them both at home and in school the components of galvanic corrosion, intergranular corrosion, how the wing spars are made, and also the inspection methods. They studied eddy current, they studied ultrasound, and they studied visual inspection. And I'm really proud of what they've come out with, and I hope you enjoy it as well.
All right. So right here we have a Piper wing that we took off from an old aircraft. We thought we'd show you how it attaches. Right here is the forward attachment fitting with a steel bushing. Over here it has a bit of surface corrosion. Back over here is the main wing spar, which attaches the wing to the aircraft and is where most of the structure is. These two bolts under AD 2020-2616 are to be inspected with eddy current to detect any possible cracks. And back over here is the aft attachment fitting.
I'll be doing an inspection on the main wing spar for intergranular corrosion. I will be using a 10 times magnifying glass, a picture on my phone for reference of another aircraft, and the AC 4313. We've learned about ways to test a part for any sort of stress. We've learned about non-destructive and destructive testing. Non-destructive testing is when you inspect or test a part without damaging it, therefore it can be used again. Examples of this are eddy current or dye penetrate. A destructive test is when you break a part in order to either inspect it or learn something from it.
So right here, this is the gusset, and we're able to give you unprecedented access because it was removed here, and as you can see, there's no intergranular corrosion. But when we check on the part, we can see some surface corrosion, and when we turn it, there's also some surface corrosion. And I also have the service bulletin 1244C on the aft wing attached fitting. We are able to give you unprecedented access because this piece used to be over here. And here's an example of galvanic corrosion. As you can see, a barrier was applied at the factory for galvanic corrosion, but it failed.
They've really taken a deep dive into what these ADs mean, and we hope that you enjoy what they've learned. All right.